Hi, and welcome to Geometry for part one of what will be an excellent journey. Today we're going to be starting off with some basic review of angles and specifically looking at the power of transversals. Are you ready? Here we go. Today we're looking at transversals. Yes, it is those straight parallel lines cut by another line. So we're looking at these things, and you're going to have to just imagine that I can draw a freehand straight line. Now we're going to call those two lines parallel. Again, you have to use your imagination, but I'm going to put little signs here. That means that it's parallel. And a transversal is any line, any straight line that cuts two parallel lines. So that green line is a transversal. And transversals are pretty cool. I mean, all math is pretty cool. But transversals especially, because they have a really cool property of things being equal. So I'm just going to put some x's here, and everywhere you see an x is the same value. So they're all equal. And I'm going to put y's here, and all the y's are also equal. Now there's something also really cool about an x and a y. Yes, they are two letters in the alphabet, really popular letters actually for math. And if you add them up, if you add x plus y, it always equals to 180. And since we're talking about angles, we're going to say 180 degrees. Well, that's pretty neat. Now, some previous knowledge that you have to remember is that when you have two lines that cross, you get something called vertically opposite angles, and vertically opposite angles are always equal. So vertically opposite, okay? So you have to remember that. And you're going to get some other kind of really interesting things in this transversal. We're going to call these things, so see, it kind of makes like a hard C, like that. And we're going to call those interior angles. So those are interior angles on the same side of a transversal, interior angles. And what does x and y equal? 180. Well, that's pretty cool. And we're also going to have exterior angles, and maybe I'll use, oh, it's a good color, maybe some gray. We have the exterior angles, so bear with me here. This is going to be the gray stuff. So these are the exterior ones. So these are exterior, kind of the outside stuff. So exterior and exterior. And also an x and a y, also equal to 180. And then what else are you going to have? You can have opposite angles. In an opposite angle would be stuff like these are opposites. And obviously opposite angles are equal. And all sorts of things. So you can see a lot of different patterns and a lot of different equations that can be created by this transversal. So let's get to it, shall we? It disappears there. And now I'm going to start giving you guys some questions. And we'll start off really basic. So here's, again, a couple of parallel lines. I'll say that they're parallel now. You can never assume they're parallel. Your teacher should always indicate that they are indeed parallel. And let's say you had this being 5x plus 10. And by this, I do mean this little angle here. So say this is 5x plus 10. And then let's say, oh, I don't know, this angle here is x plus 2. So that's x plus 10. Make that a little bit nicer, x plus 10. And that's x plus 2. Well, again, go back to your transversal laws, and do you remember how are those two angles related to each other? Well, again, maybe I should just leave this little diagram over here. I'm going to go the opposite way. Whoa, that was crazy. So you have x and x and x and x, and you have y and y and y and y. So try and find those two. So you have like an exterior angle and an interior angle, and that means that they're going to be equal. Okay. So what's your equation going to be? It's going to be 5x plus 10 is equal to x plus 2. Just like that. So let's go do some quick algebra, because algebra makes everything better. I'm going to subtract x's on both sides, and I'm going to subtract 10 from both sides. So I'm doing a couple of steps at once because we got things to do here. So we end up getting 4x equals negative 8. And I love it when my examples end up being weird. X is going to be negative 2. Negative 2. That's a horrible question that I have created, isn't it? Why is this a horrible question, Mr. Douglas? Well, I mean, mathematically, we've done this all correct. It's also very sound. But this is a problem when I start thinking of numbers, when I start making this video, just off the top of my head without even trying them. If you put negative 2 into here, what's negative 2 plus 2? 0! How could that be 0 degrees? I have no idea. I put negative 2 into this one, it is also going to be 0. So, okay, so mathematically it kind of makes sense, but it doesn't in terms of you really can't have that picture looking like 0 degrees. Sigh. But you get the idea? And that's the important part. Maybe next time your math teacher will have an example where the numbers actually work. But theoretically, that was how you go and solve it. Okay, let's see if I can restore your confidence in me. Don't click unsubscribe, that'd be so sad. Let's try another one, and I will promise you, yes, I'm going to promise you that these numbers will work out. I'm confident. Let's say this is 4x plus 15. And let's say, let's just kind of differentiate some colors here. And I'll say the other interior angle is y plus 16. And over here is going to be y minus 10. Okay, so I want to know what x and y is. And I heard somebody say that as they're looking at the screen. Are those parallel? They are now. Whew. We're going to color in the little arrowheads. There we go. Lots of fun going on today. So where would you start with? I would start with the y's first. And again, this goes with some previous knowledge. This is a straight line. And what does a straight line equal? Those two angles, what were they going to equal? They're going to equal 180. So straight line laws. So this whole straight line is comprised of two different angles. So these have to equal 180. So you would end up getting y plus 16 plus y minus 10 would have to equal 180. Okay, so let's just go and do our handy dandy algebra. And I'm kind of going a little bit fast here, for sure. I'm going to cut 174 into 2, and I think that would be, is it 83? Is it 83, was that right? 174 divided by 2. 87, I was so close. 87 is a really cool number, though. 87, for those of you who don't know, that is Sidney Crosby. Who is Sidney Crosby? Just the best hockey player in the world currently. Sidney Crosby plays for the Pittsburgh Penguins. Good Canadian kid. So y is going to be 87. Excellent. Then what you have to do is put this 87, put this handy dandy 87 right where y is. So what is 87 plus 16? So 87 plus 16 is going to give you 103. So you now know that this angle here, this whole angle here, is 103. So if I was going to go and kind of redraw this, you know that this angle here is 103, and you know that this is 4x plus 15. Well, what do you know about those two angles together? Well, according to transversal laws, if I add those two things together, so plus 15 plus 103, that would have to equal 180. Awesome. So I'm going to go and do my math, and I'm going to get, what's that going to be, 118 equals 180. I'm going to go and subtract 118 from both sides, and I'm going to get 62. So 4x would now equal 62. And I would divide that by 4, and I'm going to get 15.5. So x is 15.5. So I've solved for y and I've solved for x. That is extremely exciting. And there we go. One little thing is, always make sure your teacher is either asking for what x and y is equal, or what are the angles equal to. Sometimes teachers will actually have you go and put that value for x right back into right here, and actually tell me what the actual angle is. So just kind of be aware of that. Just make sure that you're reading the question really carefully, so you know what you're doing. Now, what other kind of things do we have to show you guys? I love transversal stuff. Transversal stuff you can kind of show a lot of different ways. So I'm going to show you a little trick. Yes, we are ready for a trick. So let's get rid of that. So it is trick time. Trick time. And so I'm going to show you something a little bit challenging, kind of a pretty neat question. And I'm going to give you guys two key things. So two key things. The first key things, a little tip for you mathematicians out there, is always think about extending lines. And I'll talk about each one of these separately. The other thing is to think about what would happen if I add an extra parallel line. Sometimes that will help you. And the third thing is, what happens if I cut an angle, and now I'm going to be in two pieces. Notice I didn't say in half, in two pieces. Cut into two pieces. I'm going to put a green box around it. It must be important if I put a green box around it. So we're going to use those ideas for the next following question. There we go. And I'm going to do a little Pac-Man. Boom. Boom. See the Pac-Man? And I'm also going to do this. Do there. And like this. It's almost like an arrow, isn't it? And I'm going to say that these two lines are parallel. Okay. So what did I say for tips? Extend lines. So I'm going to go and extend lines. So I'm just going to show you. Like, I'm just going to make this just whoop. I'm just going to extend it. Look, I'm just extending the lines. That's cool. And I don't know. Do you guys see the transversal? Do you see it? I'm going to extend this line. And heck, why not go and extend this line? Like that. So I've gone and extended lines. Now, obviously, you're going to need some information here. So I'm going to go and write in some stuff for you guys. I'm going to tell you that this angle here is 40 degrees. And I'm going to tell you that this angle here is x degrees. And over here, I'm going to say this entire angle is 77 degrees. Okay. So what were my other tips? My other tips were what? Add parallel lines and cut an angle into a couple of different pieces. Uh-oh. Where did my other stuff go? You don't know this, but I have special little layer things that I work with here. Here we go. Let's get rid of that. Boom. There we go. It's back. So I'm going to go and add a parallel line, and I'm going to cut 77 into two pieces. Whoa. I just added another parallel line. That is pretty cool. Now, I want to spend some time talking about the idea of what I just did to this angle here, this 77 degrees. The common kid mistake, the K, M, and if you're joining me for the first time, I know, common is spelled with a C. Hopefully you're laughing now. When I cut this into two pieces, I did not cut it into half. So a lot of kids think when I did that, I actually made that into 38.5 degrees on top and 38.5 degrees in the bottom. No, 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 no. I cut it into two pieces. This piece, and I cut it into this piece. So two pieces that add up to 77 degrees. Okay. Well, let's go and deal with which part? Let's just deal with the top part. There's a couple ways you can do this. I would use straight line laws. So this straight line right here, do you see this straight line? I like all the colors I'm using today. So a straight line. So if this part here is 40, what does this other part here have to be? So hopefully you can kind of quickly do that in your head. This would have to be 140 degrees. Right, straight line laws, 140 plus 40 is 180. if this is 140 degrees, what does this little blue piece here have to be using transversal laws? Remember, this makes a 180 degrees. Well, that means this part here has to be 40 degrees. Well, that was exciting. And if that piece is 40 degrees, this little piece here is 40, right? This little piece here is 40. What does the other part of the 77 have to be? Well, that would have to be 37 degrees, because together it has to equal 77. So I just know that those two pieces now are 40 and 37. So I'm just working my way down, using my transversal laws. It's pretty cool. So 37 degrees, and oh my gosh, is x equal to that one? It is instantly. I know that these two angles are equal according to transversal laws. So x is equal to 37 degrees. And you just saw so many cool tricks. You have cutting an angle into two pieces, extending lines, and adding parallel lines. You've got it all. Go and tackle those transversals. Good luck. Thanks everybody for tuning in to this little tidbit on geometric stuff. Thank you everybody. Go subscribe. It's either down there, it's down there, I don't know. Click subscribe, get me to 100 subscribers, it'll be awesome. Thanks for sticking around, listening to some things about angles and transversals. Until next time, have a great day.